Morning, good afternoon, good evening. My name is Adrian Burke. I'm from the DB2 SWAT team at the Silicon Valley Lab. And I'm excited not to be doing this presentation on Friday at 8 a.m. after the Thursday night concert. So the title of my presentation is Maybe Profiling Isn't Always a Bad Thing, in DB2 that is. So what we're talking about here are system monitor profiles. For the agenda, we're going to go through what they are, what they were designed for, how you can use them to manipulate special registers and navigate the continuous delivery model in DB2 12, talk about controlling connection usage, as well as thread or DBAT usage, and finally, how you can monitor the monitor profiles. Of course, it wouldn't be complete with a little jab at the TSA. The idea here is that as part of the profiling, you need to determine who you want to let in at all, as well as how many concurrently you want to allow in. Maybe letting everybody in isn't the right answer. So you'll have to allow me a few mistakes maybe in this presentation with my acronyms. I'm just coming back from a 5-month deployment for the Air Force. So I've got to segue back into IBM and mainframe acronyms away from the ones I was using overseas. So getting started with monitor profiles, what are they? Well, it originated back in version 8, and the idea was to give more granular purview to ZParm and system parameters. And back then, it was mostly just to manipulate, say, special registers. And in version 10, we came out with a way that you can manage some of the distributed environment or help you protect DB2 from the distributed environment. So they can be used to either warn or limit consumption of DB2 resources. So it's mostly about threads and connections. We'll talk about special registers as well. And they can be in the form of a warning or a profile. Obviously, a warning just pushes out a DSNT 77 message into the master job log. An exception is going to take action on your behalf. It's autonomic. So the main things we're managing in the distributed environment are connections, i.e. related to ConDBAT, threads or DBATS, which is a more granular max DBAT, and of course, monitoring idle threads, which is similar to IDTH-TION. And the special registers, now these can be very powerful. It's the first topic we're going to go into to manage things like current degree for parallelism, current package path, which collections these distributed applications are coming after, and so on. So they're implemented in DB2.10, available in new function mode, and the DSNTI JSG job is the one that sets these up. So these are 4 tables that are within the catalog. And for you to manage, create, start, stop, delete profiles is all via SQL against the catalog. So insert, update, delete. So the 4 tables, the first one's the DSM profile table. That's what you're filtering on or who you're profiling. Profile history. The main thing you're looking at there is a status column to see whether or not you were accepted or rejected for the profile you tried to set up. Profile attributes is which resource you're monitoring. So threads, connections, or special registers. And attributes history is going to tell you whether or not it was rejected, or why it was rejected, more importantly. So once defined in the catalog, they've got to be started. So once you create them as started or stopped. You can also use that command, and they become active when the DBM1 address comes up. So that's where the monitor lives. Of course, if you're monitoring things like threads or connections, DDF has to be up as well for you to be able to manage anything. There's an auto start ZParm that came out several years ago that we'd certainly recommend having on, so you don't have to automate a command to start them when the dist address face comes up. We're going to jump right into special register usage in here because it's definitely pertinent to version 12, the idea of continuous delivery. And you can manipulate the special register of the current package path. This is important so that you can point inbound connections to the right collection ID and package you want them to use. So it's a great way to take that burden off the applications so they don't have to set it within their own APIs or, .NET or anything else. So we've had customers toggle between old and new collection IDs using this. So this is a great thing today. We know it's almost impossible to break in and rebind the null ID collection, which is all your dynamic JCC packages, the sysln, syslh, 1, 2, 3, 400. So they've been able to do this by setting up a generic profile against auth ID and wildcard it. So that just means I'm going to set up a profile that covers every inbound connection or thread coming in. And if I want to push it to a new collection, I turn on this profile that absorbs everybody, and I say use this current package path, which is this other collection. So I rebound it on the new release or with a different Apple compat for a different feature function, and I point these guys to it. So that'll bleed off most of the connections as the transactions commit. They'll be on the new collection ID, and then of course you may have some hangers on you'll have to take overt action against. And this will also help you in the performance department if you want to segregate well-behaved applications to take advantage of things like dynamic for the local statement cache, release deallocate, which is for high-performance DBATS, and parallelism using degree. So the version 12 function levels in continuous delivery, you're also probably going to want to segregate based on which applications are moving forward, taking advantage of new feature functions in the new function levels, and those that are basically stagnant. Because if they don't want to bother testing to see how they react to new feature function, right, which was the point of Apple compat to break apart the DB2 subsystem migration from application migration. So with Apple compat now, you'd want to segregate these packages so that the old applications don't need to bother testing against new feature function if they won't use it. So our general recommendation is to have 2 collections at least. So we're talking about dynamic JCC stuff, the null ID, which is your default collection as it is today, and then you might want to have a null ID 50x. I don't know if you want one for function level or just one that's new that allows them to use all the new functions. But at least 2 so that you can have your sub applications that don't need to test and they're just kind of dormant, and then those that are moving forward and exploiting new features. Another reason to do this is that we've implemented a new parameter, and this parameter is in the driver. So either JDBC or .NET. It's called the client Apple compat parm. JCC specific here. So there's an incompatibility where you need at least the DB2 connect level or driver level 11.1 fix pack 1. You need that min level to understand what client Apple compat parameter is. So the idea here again is to delineate you migrating DB2 function levels and keeping those current while also having to manage migration of the driver. So we're segregating these so that the driver has to be somewhat current to exploit new feature function. The idea is we want to protect you in case in the future we in DB2 change the DRDA flow. If we do that, at that point in time, we'd have to force you to a new driver level. Using this client Apple compat, you can tell us what level you're expecting, right? So that we don't break the applications. Now, there's a big pushback from customers when we put this out and said you mandatorily have to flow client Apple compat if you're going to use function level 501 and up. So we put out the PH 08482 that allows the client Apple compat to be optional. So you don't have to flow it, but you need to be on v11.1 fix pack 1 period if you're going to exploit function level 501 or higher, meaning if you're connecting to a package bound with Apple compat 501 or higher, you need to be on that driver level and to flow. Well, and this APAR makes it optional to flow it. So again, if you choose not to mess with this client Apple compat parameter, the onus is on you, Mr. Customer, to ensure and test and make sure that, if we did put out a change to the DRDA flow, that wouldn't break an application. So I give a little visual here to try to help explain this. If you're on a down level driver, you can always connect to packages bound at Apple compat 500 or lower. You cannot, however, connect to Apple compat 501 or higher. If you're on 11.1 driver and you're flowing the client Apple compat parameter, you cannot connect to a down level package, either 500 or below, but you certainly can 501 and up. So this is just something to take into account as you're planning your step forward. So even with this APAR that makes it optional on that, so you don't have to flow the client Apple compat, then you do want to keep an eye out if DB2 ever announces that we're going to change the DRDA flow, because you want to make sure you test it. But if either of these scenarios depicted at the bottom occur with a red arrow, you're going to get basically a denial of service. So negative 30,025, the connection's actually rejected if you have a down level driver that tries to connect to a package bound at 501 and up. And we've have had customers who've done a massive rebind on their JCC packages and basically denied their own service. So something to be aware of. So of course, you want to rebind the JCC packages, that null ID collection, with a applicable Apple compat level as you migrate up through the different function levels. We put a job in there, the TIJLC, to help. It's basically a bind copy to copy those null IDs over. But again, that doesn't help you break into them. And as we know, dynamic packages are almost always in use. So the way to fix that is you either have your applications change which collection they're going after using current package set, current package path, or as I mentioned before, you can use a system monitor profile to force them to the correct collection ID. So as long as you know which application or auth ID or so on wants to exploit new feature function, you can set up a profile on their behalf. They don't have to worry about the inner workings of DB2. Now, hopefully in function level 505, the bind breaking is going to help with these distributed apps so that you would be able to break in doing a rebind against these sys LH100 packages. So of course, I've got an example, setting up a system profile for a collection ID. You notice a highlighted line, I've got an auth ID asterisk. So that's every auth ID. So in this one, I'm trying to catch every inbound connection request, and I'm going to push them over to the current package path of null ID 501. So they're going to use that new package bound with a new Apple compat level of 501. So transitioning back now, we're talking about managing DB2 resources and protecting those resources. What are the other profiles I can set up? So in the attributes table, I can define if I want to monitor connections, threads, or idle threads. So for monitoring connections, it must be lower than the con dbat zparm. Kind of makes sense. You're kind of subsetting it. So if you set this to a warning or exception, the first connection after that limit trips the profile. So if you set it to a limit of 100 connections, 101st puts out a message for you. Monitor threads must be lower than max DBAT, of course. And it's a total number of concurrent active remote threads. Well, I mean, they could be active or inactive depending on how this is bound, but it's a thread with, for instance, that auth ID, whether they're doing actual work or not. Monitor idle threads. So this is obviously for your timeout value could actually be greater or less than idle thread timeout. So that's an interesting option. So usually idle thread timeout is set to the worst behaving application in the system. This way you can give them a higher idle thread timeout for that end of month VP report that takes 30 minutes, right, or 30 minutes of inactivity. Give him a 30-minute timeout and put your subsystem parameter back at 120 seconds, which is default. A warning here. So if you set up a warning or an exception for the monitor idle threads, anything that qualifies for that profile no longer abides by your zparm idle thread timeout. So if you just put a warning on there to observe how long this thing is idle, it would no longer abide by idle thread and you could allow it to run forever. So for each warning profile you put in for idle thread, you need an exception profile against that same criteria to make sure that they still would time out. If you're looking to utilize this and you need a starting point, I'd point you towards the statistics report, SMF 100s. If you look at the report there, the high water mark for active and disconnected DBATS, that's going to help you understand how many total threads you've got in the system at one time, and then the total remote connections. These could be associated with a DBAT or just inactive connections. But you want to understand what your high water mark there is. Also, IFKIT 365 can give you the detail behind that. Of course, the stats class 4 includes IFKIT 402, which has information on profile activities. And we'll talk about a more granular way to monitor that in a minute. So here's a little chart I created to help you understand, based on what you profile, what your criteria are, you monitor on, has a different action point within the profile. So if I'm filter on location, I'm looking at a specific IP address, generally speaking, you can use that to monitor connections. And as I said, if you say 100 connections, the 101st one triggers the profile. If you use location against threads, so you're trying to limit the number of threads from a specific IP, like a WebSphere app server, this is going to allow X number of concurrent active threads. So if you say 100, it's going to allow 100 threads in there running actively, and then any threads above that, it's going to queue up until it hits con DBAT. So we'll take these requests, we'll put them in a suspended state so that you don't have more than 100 acting concurrently. And then as each of those 100 finishes, another one can come in behind it. Other things like product ID. So if you want to look at driver levels or something to try to get rid of some of the old ones, for monitor threads against any of those, if you say 100, we're going to allow 100 in, then we're going to queue the next 100, and then the 201st one gets axed. So in this case, the 2x plus 1 number is when you start rejecting. The other ones will keep and wait. For auth ID or role, same as the 2x plus 1, and the same for the client accounting parameters at the very bottom. If you do a monitor thread against those, we're going to allow 100 to act concurrently, queue the next 100, and kill the 201st. Here's some example profiles we set up. It's kind of based on the profile ID table, but not all the columns in there. I mean, the profile table. The profile ID is a correlation between the profile and the profile attributes table. And in here, example, I've got was prod splat. So any WebSphere production auth ID that comes in for that member, DPG1, I'm only going to allow 100 threads to run concurrently. And it's going to take exceptions. So I'm going to have 100 come in, the next 100 would be queued, and the 201st one, I would actually sever his connection at his, when he first requested, I'm going to kill that 201st one. And there's other ways to manage that I'll talk about later. Profile ID 2 is talking about the JCC driver. So in this example, JCC 03, the JDBC 3.0 spec has been shelved, for lack of a better term, so for over a decade. So we're not producing any more functions in there. None of the new cool stuff like Sysplex workload balancing is in there, and you need to move to the 4.0 spec. But anyway, that profile is enabled with a warning DIAG level 2, which means I'm just going to get a warning in the master job log. And for the last one, for location, SVL IBM, I'm going to allow 100 connections in there, and the 101st connection is going to be severed. It'll be rejected upon entry. So here's the verbiage to describe those profile IDs I talked about in the first page. And I list the messages here. So for the profile ID 1, because I've got a DIAG level 3, so there's basically 3 levels. There's 1, there's DIAG level 2, which is a little bit more information about the thread or connection, and DIAG level 3 is, it'll show every occurrence and all the information we have. Well, if you're trying to get to root cause of who is overrunning your system, you need DIAG level 3 because you need all the information about the threads, auth IDs, IP, everything. The only problem with putting DIAG level 3 is that you get a message in the master job log for each occurrence. So if you have a denial of service attack and you got 40,000 connection requests coming in, you're going to have 40,000 messages in the job log. So if you don't like that, you can back it off to a DIAG level 2, right, when you insert that row into the profile table. And then you're going to start the ifkid 406. And then once that's started, you can run a trace against it, and then you'll see each and every occurrence of this thing without having to fill up the job log. And I think we've covered the rest of the information on here. So how lenient should I be for this? This is just taking into account some customer scenarios where they had to go back and revisit their ideas of profile. So if I've got 3 separate auth IDs, in each one I'm going to set a profile to allow them to have 500 threads. That means each one of those, for instance, if I use auth ID, each one of those could have another 500 queued behind them, right? So if they do reach their limits, I'm going to have 1,500 DBATS tied up, right? They're allowed to use all 1,500 simultaneously, and I'm going to have 3,000 connections because I've got another 500 from each auth ID that are in a suspend state waiting to run, but they're still using a connection. So you want to be able to do the math and map out how many of these resources you're willing to allow these guys to absorb. Same thing, talking about limiting a location. If you've got several of them, they're limiting to 500 or 1,000, whatever, those can add up fairly quickly. And even with if you're limiting threads, if you allow enough to queue, those are still counting against con DBAT. So you may have to jack that up so that you don't end up running out of connections for the well-behaved apps. Now, how do I monitor what these profiles are doing? Well, if you do a display of, the display DDF detail, it'll show up in a DBAT, inactive DBAT. Display thread, the status is going to be RQ if it's suspended due to a profile. But the best way to look at, from a holistic view is looking in the statistics report. And it's interesting, we're gonna increment the DBAT conq max, which is normally associated with hitting max DBAT. So if you see this number incremented and you have profiles enabled to limit threads, so it's an exception profile, limiting number of threads, when we hit that, we will increment what is normally the max DBAT counter. So that's why I've got this graph down to the right-hand side. So I've got DBAT queued is actually caused because the profile is hit, and then the inactive DBATs, some of the inactive DBATs, which is also in stats, is going to be incremented by the number of threads that are suspended waiting to get in. But then if you have alerts set up against hitting max DBAT and these counters being incremented, you're going to want to go back and reassess those so that you also include the fact that it could be incremented by a monitor. Another recent enhancement is the attribute 3 column in the profile table. If you put a number in there, you can actually limit the number of DBATs that are queued due to a profile. So you can limit the queue depth. Previously, the queue depth was equal to the number of concurrent threads you allowed. Now you can control that. So maybe allow 500 in the system right now, and you only allow a queue depth of 100. Then you'll start rejecting. Okay, let's talk about some common problems that customers run into. So controlling connection usage. Common problem is applications gain and hold connections inevitably. There's a litany of reasons why this might happen. They don't release their logical connections in the application. They're not using pooling appropriately. A big one we see recently is that there's validation queries coming from the app server. So these are, open source app servers that are used to very inconsistent or unavailable DB2s databases, so that they'll go out and ping the database every couple seconds to make sure it's still alive. That's a good one for keeping connections around. There's no timeout value set for the connection pool. Sysplex workload balancing in the driver actually helps eliminate these frivolous connections. So if you don't have that on, I want you to realize that the DSNL 7.4 message would go off at 80% of con DBAT, and it's something you definitely want to alert on, because you don't ever want to get within 80% of con DBAT. If you're using workload balancing, it can affect the workload distribution, and it's also a warning that you're getting really close to the edge. Let me throw a customer scenario at you. This is a Monday morning at a customer. You look at the left side of the screen. They've already got about 600, for this gray in the picture, or 600 inactive connections. The orange kind of at the bottom are active threads. So you can see them ebb and flow, but these connections continue to grow and grow and grow over time. And eventually in this picture, about 1 o'clock in the afternoon, they don't hit max DBAT, but they hit con DBAT. So the red spike there is connections being rejected. So that's the denial of service on this DB2. It is rejecting legitimate requests for a connection to DB2. Well, what happened? Well, the DBA went out and did some display commands, found the owning IP address for the connections, found the app owner of that IP address, called him. He's like, "What are you doing?" He's like, "Well, I don't know. I just got back from lunch." He's like, how many connections do you have to DB2? I need you to drop them. He said, "Okay, let me close my spreadsheet." So what had happened was he had some OLADB connections to it, and every time he opened a new tab or ran a new task, it kept the old connection and created a new one. There's no connection pooling within his spreadsheet. So you can see how just something as simple as that, seemingly innocuous, right? Not intending to do any harm, could bring down a production system. So recommendations here, I think pretty much every customer should have a wildcard set up for monitor profile and monitoring connections. So if I set it on this IP address of 0.0.0, maybe just a warning. So I'm just going to get a message in the master job log, and I'm going to say I want to be alerted when we pass 100 or 1,000 or 10,000, depending on ConDBAT, just to keep an eye on what's coming in and then understand what IP address is doing that. Because this profile right here will give you an alert if an individual IP address surpasses your limit you've set. Of course, you can always do display location detail. You may want to keep a spreadsheet going over time. Display thread type inactive if you need to get the auth ID or more pertinent information on where those IP addresses are. And then once you get comfortable after monitoring for this for a good amount of time, then you go out and you put an exception level in. And then you're going to start rejecting some of these connections because you're comfortable with what normal is. Another option, of course, is to enable Sysplex WLB. If you know my name, you know I'm a proponent of enabling Sysplex workload balancing. And this can help even in a non-data sharing environment. If you're a standalone member, it avoids abandoned connections that are just out there that'll never be used again. And it also can avoid stale connections because they've hit an idle thread timeout or the application is timed out and the connection's still there. The next transaction that tries to use that connection from the pool, that connection is going to blow up because it's no longer valid. So enabling Sysplex WLB, the driver itself goes around and cleans up those connections if they haven't been used after a certain number of time, which is about 10 seconds. And if you do this, you also want to set ConDBAT on each member to about 1.25, defensively, 1.25 times the total number of connections you're going to see in the environment, because the max connections coming out of each connection pool, right, are going to determine what your ConDBAT really should be. Because ideally, you don't want to deny any possible connection coming from your environment. Of course, the downside is most of these connection pools and the application servers have been set up arbitrarily and continue to get bigger. But again, you've got to be, it's a mix of being defensive to protect DB2, but you've also got to be lenient enough, right, that you don't deny somebody entry who needs it. The other big problem we see is obviously applications gobbling up threads. Some of this, could be a lack of commit. I've seen customers whose applications intentionally do not commit because if they did, they'd have to re-authenticate every X number of minutes. But if the thread if the thread is still active in the system, then they don't have to re-log in. Other things, keep dynamic, declare global temp tables and held cursors can exacerbate this. Use of validation queries. This number one foul right now, I see a lot of our financial customers, they've got application servers out there that are doing select from system1. So now you're using a connection, using a thread, and it's basically, 2 threads for a single transaction that you're going to want there. So if you go in there into the validation properties and just delete that. You see customers with an overuse of release deallocate. In this, I'm talking about the use of high performance DBATS. I've got another section in this a little later, but if you bound these JCC packages, right, your sysln, syslh, with release deallocate, and you execute a modified DDF package row command, you will have high performance DBATS, which means that thread and connection are a 1-to-1 ratio, and the thread doesn't go away until the connection drops. So customers using this to try to get a performance benefit out of it without really testing or allowing, just their well-behaved applications to do it. If it runs rampant, they'll definitely have a shortage of threads. You can actually end up burning more CPU than you're saving. So all of this, we end up, with these resources being abused, we get a flood of connection requests coming in, bogs down the system, more threads and connections pile up. Remember, we need a DBAT to authenticate after the connection before we actually create the enclave and let the SQL run. And that part of it, right, that authentication is not zip eligible. So if you are a customer who's implementing things like SSL and encryption now, realize that that's an enormous overhead going from no security to SSL encryption. That overhead on the going from nothing to that authentication, is a 10 or 100x increase in CPU for that portion. That tiny portion of authentication can go up by 10 or 100x. So just realize that encryption is not free. So recommendation, remove the pinging or validation queries, period. Set up a profile, set up a monitor profile with a warning, just to get, to understand what normal is, what a baseline is, and you can then figure out, which auth IDs or which transactions use how many threads concurrently, because you can't tell that through accounting records or stats or anything else. Profiling is the only way to understand how many truly concurrent threads each application has in your system at any given point. So you start off with an initial setting, look at your high watermark, and the sum of all your profiles would definitely probably need to be to equal that number if you're trying to monitor all of your threads. Start with a warning, move on to exception once you're very comfortable and you know what the results are going to be. That's a special message that it gets back through the DRDA flow, so that the application is going to need to capture that new error message and understand that he was rejected because you wanted to with that special error code, right? It wasn't a denial of service or DB2 went down. Monitor idle threads, you can play with that with the profiling. Just remember to always set up an exception with any warning when you have. If you have cyclic spikes of threads, which we all do, but in some customers I see every 10 minutes or so, right? It'll go from 200 threads to 1,000, for instance, because there's some kind of polling going on. If you do that, you need to look at increasing your pool and ACK value, because we don't want to clean up threads and destroy them if they're going to be used 10 seconds later. That actually ends up burning quite a bit of CPU in the dist address space. And before you implement high-performance DBATS, you want to segregate your well-behaved applications from those that are not, and only point those guys, maybe via a profile, to your release deallocate package. Okay, so here's some examples of how to set it for idle thread and also for the null ID collection, just to give you an example. Okay, so I'm going to switch gears here and go into high-performance DBATS. It's a little about monitoring, but also what they are. So the high-performance DBAT, again, came out in version 10. We're allowing you to use a release deallocate bind option against a DDF thread. There's two parts to it. You bind the package deallocate and then use the modify DDF command. It's that combination of the two that allows these to take on a high-performance DBAT role. And of course, to toggle them off, you can do a modify DDF package rel to toggle it on and off. So customers didn't realize, they assumed the number of threads would increase incrementally, but I've seen customers go from 10 or 100 threads to 1,000 in some circumstances. And why does that happen? So now, using high-performance DBATS, each connection is basically going to hold on to a DBAT until the connection goes away. I know most of you folks, once you cycle DB2 or your app servers, when the connections come back in, those connections will stay there through the life of DB2 until you recycle it again. So realize that each of those could hold a DBAT if you enabled hyper DBATs across the board. So if you've got 100 transactions with a lapse of 10 milliseconds, previously, if they weren't serialized, they could end up running on one thread, right? If they weren't really concurrent, if there was a microsecond in between, they could end up funneling down to one thread. If you turn on hyper DBATS instantly, you're going to go 100 wide on the threads. So I've got a little animation here. So look closely on the right-hand side of the screen. So on the left side, the no hyperf, each one of those connections can end up going through the active DBAT through a single DBAT, as long as there's a little bit of a gap in between the executions. If you look at hyperf, each one of these coming in is most likely going to use a new DBAT because that connection is going to stay around forever. So you got to be careful how you implement it. For a safety precaution, the high performance DBATs will only execute 200 times, and then we'll recycle that thread under the covers with no real performance impact at all. But that still doesn't save you from how many concurrent threads you're going to have. And a reminder here for the timeout values in your zparms. Idle thread only works against threads which are active, which have not issued an SQL statement in X number of seconds. Cool in ACK is against the dormant kind of the DBAT, the control block in memory. If that DBAT hasn't been reused by some application, doesn't have to be the same one, in X number of seconds, we'll throw it away. But if you use high performance DBATS, pool and ack now becomes the method to blow away that hyperf DBAT if it hasn't been utilized in X number of seconds. So it becomes it becomes much more helpful in a way to parry down the number of concurrent threads you have with hyperf, because it'll time them out if they haven't been used very frequently. So remember, we want to budget because that connection is going to be there. A good rule of thumb that we like to use, if you look in your accounting short report for your DBATS, maybe based on auth ID or correlation ID, you look at the number of commits times the number of conversations, CUNVI. If that product is greater than 200, you're in the green. That's awesome, because we reuse the thread 200 times. If that occurs 200 times before it deallocates the connection, then you're going to get the best bang for your buck. If the connection deallocates after, say, 5 uses, then you're actually incurring an overhead, because for us to destroy that high-performance DBAT and create a new one and reallocate it does take some CPU cycles. Remember, if there's a slowdown in this, and the app servers, which we've seen in many cases, if the application senses there's a delay, he just starts going parallel. You know, just like you getting annoyed at your web browser and hitting enter several times, each one of those becomes a connection and becomes a new thread. So look at the bottom of the screen as a customer example. In the statistics report, we show a field, which is current active DBATS bound deallocate. So in that example, my graph, it's green. Anything green here are high performance DBATS that actually are not being used. Green means they're inactive hyperf DBATS. They're not being utilized right now, but they're still a DBAT. It's still held hostage because it's bound deallocate. So in this example over on the right-hand side, that green turns to gray, or inactive connections, because they recycle the application servers. So you want to monitor this in your system, see how many are waiting around, which is basically overhead, where you've got an application that's holding this thread hostage. And if they're not well behaved like that, one, you've overallocated hyperf DBATS. You need to set up some separate collections and get your better performing, more reliable, well-behaved applications in a separate collection ID and get the best bang for your buck. But in this case, if you are stuck in the circumstance where almost everybody's using it, you can always use the modify DDF package row command to turn off high performance DBATS, let that number cycle down and go away, and you can turn them back on. If in the case that you had, you know, some crazy spike that you weren't expecting, it's a way to reset the table. Okay, so if I'm trying to profile threads, what's the best way to get the information for them? Because I want to be as granular as possible. Well, this is many years old. We're talking about the client accounting information here, which can be flown from, you know, the application on the transaction connection all the way into DB2 through the accounting, through MVS and into WLM. So it certainly affects all aspects of it running on the mainframe and your ability to track it. So if you don't keep anything else out of this presentation, please take note of this chart down here that we've built. So I'm talking about the client accounting information. On the left side, I got Java, then we got .NET, a little description of it, whether or not you can use WLM to classify DBAT using that field, whether you can use a monitor profile against that field, and if there's a special register against it as well. So please take note of this. You know, the more granularly you can implement this, the better. If you can get the applications to code to the Java APIs, which our drivers now are fully compliant with the Java APIs. There's nothing special for DB2 or ZOS they have to code to. Or .NET CLI and the data source properties. You can even push out, you know, a global data source property that you want these .NET folks to abide by, and it'll take precedence. And then last but not least, of course, we've got DB2 Native REST services. So this is fairly new, but I want you to realize that these still abide by all the rules and architecture of other distributed DBATS. So you do the display thread command. If it's a native REST call, we've actually populated a lot of these client accounting fields for you. So we're trying to help you out here. Correlation ID, or if you're looking in WLM, it'll be CI. For a thread that does a REST service, it'll be DB2_REST for all of them. The workstation is going to be based on the browser you have, and the application name is going to be the actual REST service itself. So you look down in the display screen below, my ID is DB2REST, my auth ID. Next to the V437 message, you've got workstation, and this is from my laptop. I'm using Mozilla Firefox, right? And then, of course, the application name is query test2, because that's the name of the REST call we're doing. So there is one field you can manipulate on your own or in the REST call. And I want to point this out because it's going to be very useful for customers. The user agent field, the REST header, can be customized. So very simple to do that in the header of the REST service. I just manipulated this through Firefox, and I set, look at the new display, the workstation I can set to my initials. So this is a way to subset if you've got different applications calling the same service. This is one way you can help differentiate them based on this workstation field, which also can be used in WLM to classify them as well. So with that, I'm going to leave you with a couple references. DB2 for ZOS News for the Lab. This is actually a blog post that I wrote in regards to profiles. So it's a good way if you want to do a little bit more reading about it. And then some good proactive maintenance that you might want to take a look at just below that. And with that, I will thank you for your time. And if you haven't already cracked a beer during this presentation, by all means, you're entitled to one now. Thank you, take care, and hopefully we'll see you in person at the next IDUG.